Up next is our next speaker, Dr. Leo Meyerovich. Dr. Leo Meyerovich is the founder of Graphistry, which achieves interactive visualizations of 2 to 5 magnitudes more data in web browsers by automatically exploiting client and cloud GPU hardware. Previously, he researched parallel language and browser design at UC Berkeley. If you need to show a lot of data in the browser, he's your guy. Welcome, Leo.
Thanks. Yeah, so thanks. Leo, the founder over at Graphistry. Even though we have graph in our name, I was actually more for the art of graphics. We really think about what's technology to 100x the investigation experience, but we end up doing a lot of graph stuff. And so I wanted to share how we, when we talk about graph, kind of what we're thinking about. And especially once we go into the kind of bigger, enterprise, federal, and whether it's like security fraud, anti-human trafficking, like kind of what are the scale issues and kind of what are different, not just performance, but actually like overall kind of scale issues that we end up working with and kind of tricks we've picked up. But before going into that, I actually did want to share something that's happening. So last month we actually launched on Azure, because now you could just go to Azure, spin up a GPU just like as a normal virtual machine and do cool stuff. So do a quick demo of using us with notebooks there. And then actually I realized I need power or this is gonna be a very short talk.
There's a plug from right there.
Okay, so plug is coming. All right, we'll cross our fingers. So meanwhile, yeah, so what I want to share is a kind of a fun example, and then we'll get into this a bit later, but actually as a kind of a quick who's in this room. Anybody here use anything like Splunk or Cousteau, Elasticsearch? Okay, so we do have security people here, good. And then next question, anybody using like Jupyter notebooks, anything like that? So we actually have a few hands here. So what's kind of fun is whether you're outside of Microsoft and you're using Sentinel, or you're inside of Microsoft and you're using Cousteau, you can now do little things like write a Cousteau query. Oh, thank you, appreciate it. We can now, there we go. We can now, in a Jupyter environment, do something like write a Cousteau query or a Splunk query, get a bunch of log hits. And then what's fun is Graphistry, somebody was asking about how can you go from logs to hypergraphs. We have a little library called PyGraphistry where you could just take the data frame, basically the data table of stuff, run it through the hypergraph transform, actually just popped it out in a new window here, and then we get like we automate kind of coloring, interactivity, getting time bars, all that fun stuff. This case, we haven't really started doing too much with it yet, so I'll get into that in a little bit. But this a fun example is like maybe I just want to color the events from the Matt's Notion by time. So let me just color the edges based on cold to hot, something like that. And so we can now actually see, actually I did hot to cold, whatever. But if I want the most recent events, I can filter in, recluster, things like that, and it's interactive. Okay, so just if you want to play at home or whatever, that should be fun. So, okay. Well, all right, so I want to share a few things today, kind of some of the lessons learned in building these systems. And for scaling, when we think about the end-to-end investigation experience, which I loosely define as somebody gets like an alarm, gets an email with a ticket, and then somehow has to do stuff and then finally close it. We found for using graph in these projects a few areas of particular interest. One is information foraging. So how do we build out that context, connect it together? How do we use things like hypergraphs, things like automation? How do we make that a very structured and predictable process, and kind of talk a bit about how graph fits in? Once we do have all of that data, then there's how do we make it useful? So instead of being pretty pictures or just a bunch of logs, how do we actually do sense making? So share a little bit of some of the ways we use graphs, and actually we don't use graphs sometimes. There's actually Brad Reese is in the room, I think, if you want to raise your hands. So we actually do a lot of work with NVIDIA. And so I'll talk a bit about bringing GPU computing to basically, if you could do Excel or notebooks, you can now do GPU computing. So we'll talk a little bit about that and how that's changing what we can do with graph. And then finally, this is going to be a short part of the project, but if you're doing your own graph projects, a lot of projects fail. Not just graph, but just data projects. Data is hard. And so I want to chat a little bit about that. So let's start with the data foraging problem, which is pretty core to our jobs as analysts, and kind of where graph fits in for that. So Matt shared a little bit about hypergraphs, and earlier today we talked a little about virtual graphs. And so I want to kind of maybe a slightly different spin on how we think about it and why we're enthusiastic about that. So now when we think about digital systems, we have tons of devices, and those devices are generating alerts. So maybe we have our customers have mobile phones, maybe our data center has servers, virtual machines we're tearing up, tearing down. Likewise, we generally work at interesting scale now. So we might have 1,000 employees, 100,000 employees, 1 billion users, 1 million users, whatever. We're getting all of their digital activities. Like as soon as they do anything with inside or outside our company, we're getting lots of logs on them and lots of rich, high fidelity metadata around that type of stuff. And then what's also a little subtle and a little different from how folks used to talk about this stuff is now we have APIs. So as analysts, we're expected not to just work over all that data, but we're also expected to work with all those APIs. And so when we're building out these systems, I actually find a graph to be pretty exciting here. And so I'll get into why hypergraph and virtual graph. So on the virtual graph, what I find interesting about what's going on here is actually graph as our ability to model and interact with these systems. It gives us a lingua franca for working with APIs. And so at the interactivity layer, so think orchestration, things like that, as soon as you have an entity on screen, let's say an IP address or a user account or a firewall, there's all sorts of things I might want to do to start controlling that virtual world I just described. So maybe I want to get more dots. I want to run a search. Maybe I want to drill in. I want to pull in more data. I want to kind of pivot. Could I just click to expand versus having to write a bunch of weird looking queries? Maybe I want to sinkhole something. I want to take a command. I want to kick off an orchestration, fire off a ticket. Anytime we have an entity and anytime we have an API, as a user, I'd love to be able to just directly interact with all that stuff. And we're increasingly entering a world where that stuff's possible. So actually the earlier talk today about the Microsoft Enterprise Graph is particularly exciting to me here. And so one of our kind of missions is, can we model entire system as one uniform virtual graph? So I'm going to walk through a little example where some of these ideas come into play. So, and this may resonate with folks who've worked in sort of SOC or IR settings, or in the fraud world or elsewhere. So let's say you get a alert, you pick up a ticket, whatever. In this case, it looks like some IP address from some, like, I guess, a FireEye network monitor. And then we need and let's say this is a malware callback. And so we know that some computer's phoning home, we have to investigate. So today, what this might look like is, okay, so we look at the FireEye network monitor, we pick up some metadata, we know which server it's talking to, so maybe now we jump to VirusTotal, we pick up some more metadata, maybe we get some IOCs, we want to see if anywhere else on our network, we saw the same file hash. You know what, we actually have some endpoint data as well, like we have endpoint detection, maybe we have FireEye hosts, and so we can check if any, at the host level we saw those files. Maybe while Silence still had all that VC money, you were running a POC and you still have all those Silence boxes. So we're going to check for the IOC there. We actually, maybe you're the more senior person on your team, so you actually know how to use host logs, not just alerts. And so you actually know where to look in the Windows system. So you're going to check, once you have those you're going to check there. Reality is doing all, maybe a lot of these you have centralized into a SIM, so in Cousteau or Splunk. And so you already put them all there. And so now you start doing the same thing, but in Splunk or in Cousteau. You realize it's interesting. And so now you redo all that work because actually instead of just for that week, you have to do it for like I don't know, 1 month or 3 months because things escalated. And so we're doing all this basically accessing the APIs and logs at that level. And this is kind of why you might get a little nervous about your job every day, And I think when I talk about foraging, there's actually several activities there that, like particular ones that I find that worth honing in on. One is some of those data sources I talked about require you to know that data source, where in that data source, which field, kind of actually how to use it. then you actually have to do the manual work of jumping through those data sources, or within one data source, those multiple tables. And then somehow you have to do the manual work of actually stitching it together, and a little bit of like, pull out, folks mentioned Excel, pull out the spreadsheet, kind of work through that to actually try to figure out that story. And then we have to do this not just for the malware callbacks, but maybe it's phishing, maybe it's a SQL breach, maybe it's like the strut server again, like whatever. We have to do that for all the different kinds of incident types. And so that's ends up being a big part of our job, and ends up being like a pretty painful one. And so if we listen to vendors, and I am a vendor, so grain of salt, what we see is a lot of folks promising either individual tools inside of our SOC will kind of solve entire classes of problems, but we have lots of these, so we have a bunch of tools, and then now people are selling things like autonomous SOCs in a box with magical machine learning, and so you unify it, and then you just walk away, and then this magical black box takes in alerts and sends out actions, and then we as a job, we could just take the weekend and we're done. The reality is like the SOC in a box doesn't really exist, or it doesn't actually work as advertised. And so we're kind of what we've been observing is a couple of basically three things. One is those products are basically starting to do two things. One is about 10 years ago, they started all emitting logs, and so we won that fight. Now all the tools will kind of give you back that data of what they're doing. And for the last 5 years or so, folks have been hard about vendors to actually expose APIs. And so what we've seen is that several common abstractions have emerged about how we work with security systems. Like, we have the data lakes, some weird machine learning thing. Maybe we're a little forward thinking, or we use Sentinel and we actually have orchestration. But they actually all have, so we have these basic notions, but we also have kind of this more increasingly common looking interface. And so now, as somebody who wants to work with these systems, instead of working with them individually, we can start thinking, hey, well, for all those logs, could I just have one hypergraph to kind of describe all the activity across my entire enterprise? And so whether it's at the log level or at the alert level, I just have one uniform data model. And two is, I don't want to have another stupid data lake project where I have like yet another giant Hadoop cluster and have another data duplicate. Maybe I have a virtual notion of all of this stuff, and so I could reuse my existing data silos, and so I just have a virtual graph over that. And by the way, a lot of the things I deal with nowadays are like scoring algorithms and orchestration systems, and maybe real-time EDR or something like that, like on the fly. That's all API stuff. So now I actually have a way to interact with those. And so I'm finding graph is becoming sort of this lingua franca, again, for whether we talk about hypergraph for logs or virtual graph for API, and actually for really big logs. It's becoming a way for us to actually have a uniform way of like a kind of a common foundation to build on. So it was interesting to speak after Matt at an event, so we actually could go into a little more nuance now because Matt has already introduced the notion of a hypergraph. So I want to share kind of a slightly maybe extra nuance to what Matt was saying on how we think about hypergraphs. So it's kind of a quick demo. Let's say we took that alert from before and maybe we actually had two log lines. Here what I'm just showing is kind of Matt's notion. Let me flip the colors just to increase the contrast. Maybe it's a little more visible. So here I'm showing two log lines. I'm doing those JSON logs. And then we just picked out certain of those entities as kind of, in this case, let's say the IP address in the alert column, and said, hey, let's put the source IP and the dest IPs on screen. When we say hypergraph, that's really just about the math or the underlying data model, but we can visualize it in different ways. And so the most kind of direct mapping we could do is something like, in orange, we show the individual log lines, which are the kind of the hypernode, or like the kind of the meta hypernode. And then when we looked at the log lines, we could have extracted, like for example, for this event, we could have extracted an alert, maybe the source IP, maybe the dest IP, and then for the second event, same thing. We take the alert column, we made all those red, and then we have the source column, the dest column. And so we can map them out. This is useful at the tool level, and then as an analyst, this is useful when I really want to drill in, because if I was just going to look at this, I could actually answer, oh, how many events are there on screen? Well, there are 2 orange dots, so I know there are 2 events, and I can start answering questions about what's actually going on. By the way, they're related because they both have the same blue entity, the blue device extracted. But there's no reason that when we're consuming these things that we can't just change how they look. So I could take that same graph. If I could, well, as soon as I have a hypergraph, that's like the most like kind of zoomed in rich notion of the data set. But now I could do simpler views. Like for example, I say, well, let's actually not show the event node and then just like connect all of its entities together. So that first event, we just got rid of the orange node, and instead of having everything going through the orange node, we can just now directly connect them together. For us, like that, we just make that a toggle. But like I think the more interesting thing to me as an analyst is like, I can kind of zoom out a little bit. I still want to differentiate events, and so I kind of lost that, but now I could do tricks. Like for example, I could color the edges based on the time, let's say cold to hot. And so, I don't know exactly how many events really happened here, but I could say there's something happened at the blue time period and then later something over here, but actually the common actor was this guy down kind of inside of our perimeter, but out externally there were two others. And so hopefully this start gives you a feel that we can actually model different kinds of data, but actually have a good substrate underneath. So let's jump. Now, one version of the world is whenever you have an incident, you do this manually. That we get an IP address, we get an alert, and then we just start pivoting around our hypergraph, and then hopefully we kind of understand what happened. That doesn't really scale. That's interesting from a hunter, but as soon as we do like tier 2 or anything like that, that doesn't really scale. And so what we find is now that we have this substrate, we can actually start using automation and actually making this process more scalable. So I'm gonna return to that same example. So again, we have a malware callback, and now we want to kind of, as an analyst, I know where the bodies are buried, so now I want to kind of see if we can do that. So the idea is wherever you normally work, so let's say you pick up your existing dashboard, your Azure Sentinel, your email, the idea is whenever we want to pick up an alert, we want to do all of that pivoting around that I described in that like the FireEye workflow, but we want to do it automatically and over that hypergraph, over our virtual graph. So in this case, we have the malware alert. I want to click on the ID. And as soon as I click on it, I jump into what's kind of interesting is I could actually jump into a workflow that's primed based off of that whatever investigative starting point. And you can have all sorts of workflows. So in this case, for example, when I clicked on the link, same thing as before, we synthesized some starting point, let's say that JSON log that we clicked on, but then we have lots of different steps. And this could be things like Splunk queries, Cousteau queries, virus total queries, all that stuff. We can actually have explicit instructions of how to jump over our virtual graph. When you hit the run button, each step runs. We find information. So for example, on this graph, what I might do is, for example, let's recolor the graph based on the step that the data came in. So again, we're going to go cold to hot here. And so initially, we got a bit of data here, but near towards the end of analysis, for example, as soon as we've identified a particular laptop inside of our perimeter, we're actually later in the analysis able to find later even more information. And underneath, if I ever want to see what was actually going on, I can actually jump in and see what that pivot, what that query was. Going back to Matt's notion, I might instead want to understand what's sort of the temporal causality. So what I might do is recolor based on time, something like that. So here what we actually found is indeed actually the later or hotter time period is from going from the laptop.alert. So this data is anonymized, but actually this is a real incident. You're seeing me kind of work in real time. So going back in context of kind of what I was trying to get across here is like my sense is as more of the security technologies mature, just as how we switch to centralized SIMs and being able to at least have logs greppable, we're starting to add structure and uniformity, and that as vendors kind of work together, my sense is being able to do relational reasoning is we're kind of in sort of that transition. And that actually starts, as we start adding in automation and machine learning to how we work as analysts, I think that starts opening certain interesting doors, and when we want to think about efficacy, certain interesting possibilities show up. So as an analyst, I actually want to show an example. So remember when for one of those pivots, I hovered over and I was able to kind of say, oh, here's the search for that pivot. There's the underlying search that ran over the virtual graph. What we're seeing up here is actually a real case when we're working with a particular anti-human trafficking group, actually. We'll talk about that later. Where one of those steps, because it came from the workflow is actually able to generate a much nastier looking query than I might have normally done if I was just using a log search tool directly. So if in a log search tool, if I find some IPs or whatever, I might open a bunch of browser tabs. I might run a search for each IP, right? But if a tool just automatically pivots for me, it could actually generate all those queries for me. And that kind of stuff in theory, we are doing in a log tool here. You can imagine doing a SQL tool. You could write some weird looking join. But the interesting thing is once we have a uniform compute layer and we start adding tooling around it, for a graph, that's just a very intuitive, natural notion of expand, right? Expand over the virtual graph, even if on the underlying weird whatever database systems of the day we're using make it gnarly, that's fine. And so as an analyst, it's an interesting value proposition. Okay, so through the automation, I could do a bunch of steps. So that means I could check a bunch of data sources that I might normally not do. Within each data source, we're actually going with a lot more fidelity than I normally would. I'm actually checking a lot more of that metadata that I normally maybe I just look at the file hash and the IP, but now maybe I do some extra correlative pieces of evidence that I can go further on because I'm having the machine do that for me. And then finally, I'm actually doing that in less time than I normally would have done all that browser hopping. And so this is like, there's an interesting value here, and then at the cost is actually fairly low because what I've also demonstrated is there's no reason to have to write Python or PHP or C# or whatever. You can just work in your query language. We do record and replay, and it just kind of works over your normal system. So I think these things are getting a lot more accessible. But then when we jump to the team level, I think the value prop actually changes a bit. So everything I just said was more about as a senior analyst, how we might think about it. But then as we're trying to work at the team level, maybe you're a manager and you're kind of responsible, like kind of how Matt was discussing, responsible for SLAs, you're responsible for team performance. Maybe you have a remote team and you want to talk about like kind of their best practices. Things start shifting a bit. Now that we have this ability to kind of do these uniform investigations over our kind of overall ecosystem, we can actually talk about steps, investigative steps, we can start kind of breaking it down into different kinds of coverage. So for example, I talked about malware. So if we say, if we take a perspective of different kinds of investigations, maybe a team is 20% malware investigations, 30% phishing investigations, and then now they have to deal with maybe like multi-cloud. Like they know how to deal with their Azure account, but they don't know how to deal with their AWS account whenever there's an alert on a tenant. Now we can actually talk about, well, whenever one of those alerts comes in, here's the best practice. This isn't going to be the 100% of what you have to do, but here's like, the first 10, 15 minutes, these are all the things that should be checked. So now we can actually talk about having a kind of a language and a structured mechanism for teams to actually write out those plays. At the same time, as we kind of go deeper into the investigative team, so maybe we're a tier 3 team, we're a hunter, maybe you're just really enthusiastic about your job and you're always kind of curious. Now we might want to do it more from the perspective of data. So hey, I have, actually what I hear a lot is I talk to a team and they're like, I don't really know what to do with Windows host logs. There are a lot of event codes and every year there are more, and sometimes there are fewer and they change. And most of the team doesn't have time and knowledge to do it, but all of a sudden we can actually take for different kind of data types, we can talk about how do we actually create, at least for the 80% case, create kind of coverage for ways to work over them. And so once we start getting the ability to, again, the virtual graph and the hypergraph, once we have ability to talk about the logs and the ability to talk about the APIs, we can actually start stitching together structured investigations over them. This conversation I'd love to have with people after is like, what we're also finding is somehow, end of the day, this needs to somehow have a report to management as well, like the next level of management, where we want to say, well, what is our SLA for our team? And so somehow there might be a notion of like, well, if we have 80% coverage of our different types of investigative incidents, at least for the common ones, at least we can say we'll check most of the data sources for those most common incidents. The board should be happy, or something like that. And that's an interesting question of like, is this about team burnout? So they're not doing the kind of the silly stuff. Is this about kind of providing guarantees to other organizations? And I think there are a lot of interesting things that start opening up. Kind of taking a pause here. So I shared how we're doing the hypergraph stuff in notebooks. So you can, if I'm guessing about half the audience here is at Microsoft and might have access to Cousteau. That means you could do this stuff today. We're actually starting to focus on working with the Sentinel folks around providing the automation support and visual automation for that world. That's newer stuff, so if you're interested in that, come up to me after or email, and I would actually love to work with you guys on that, or men and women on that. Okay, so let's make graphs useful. So here I'm showing two other ways of looking at logs. Sometimes actually, even in the presentation, I do like to drill into logs. Sometimes I do like to do things like bar charts. There are times they're useful, but there are other times, probably like the two I'm picturing here, where they may not be the tool for the job. So I'm not like some sort of graph extremist where like all things have to be like, you have to do graph. But there are places it fits, and I kind of want to share kind of some of those interesting places. So let's say we took those same logs, and then we looked at these pictures here. So if I wanted to look at a logs and answer how many IPs, or what are the IPs and the hashes and IOCs involved, a graph's actually pretty good for scoping. Okay, we can do that. I already showed examples where we wanted to look at progression. If I want to understand how those same entities are doing things over time, graph actually does a pretty decent job there too. The tie with machine learning actually gets pretty deep. So if you're doing stuff more on the model side, I would actually, that's again another category. Let's just have a discussion after. But intuitively, patterns and outliers just pop. But then once you start overlaying things like true positive, false positive, confidence, scores, it becomes a really interesting way to kind of call attention. And so on the right, for example, we're kind of highlighting what an algorithm identified as the critical players. So graphs could do some things that at the data level that are hard in traditional viz. So I want to share a project that was actually shown for the first time earlier this week. This is a collaboration with the Global Emancipation Network, which is working on to stop modern-day slavery. It's actually partly sponsored by Microsoft, so thank you for the GPU hours. And Accenture did some of the work on the, I think, TensorFlow stuff. And then, of course, we're doing some of the visualization automation. So the basic problem here is actually not very far from our job as analysts. So as an analyst, I might have a lot of logs from a lot of data sources, and I have to sort of put together a picture of what the bad people are doing in the systems. Apparently, you can actually do the same thing to find modern-day cases of slavery. So what that looks like is there are businesses who actually have registrations. We can actually have data indices with all those businesses and all that metadata, just as how you might have an asset inventory. And then instead of alerts, it's a little trickier. What we actually have is online reviews. So as somebody goes to some place like a massage parlor, they might talk about what things they did, and then things they might use coded language. So it's, we do have to do a bit of extraction and reasoning about that data, but it actually ends up very similar to alerts, where all of a sudden we start doing detections, and then we start kind of highlighting interesting things about it. And so I thought this is an interesting case study of where we like to use graph visualization, where we don't. So what's going on the bottom is kind of how the machine, when we're doing the machine learning and kind of working, how the machine understands that data set for that particular algorithm. So we had all sorts of kind of things like, for example, did certain words appear in the reviews? Like how many times? And so machines and machine learning algorithms generally really like numbers and like score ranges. I think that's why we see a lot of like self-driving cars, because that's just pixels. Those are just numbers, right? So that's actually, we're pretty good at that stuff. And so one algorithm that's emerged that's been kind of nice is something called UMAP. So actually, let's do this live. And so UMAP actually works fairly similarly underneath to how a lot of modern machine learning algorithms work. It's a little different, but for our purposes, it's close enough. And what's going on here, and this is actually real data, so I can't actually drill down too much for folks here. I don't want to be liable. But what's going on here is in gray is just basically the UMAP algorithm looked at all those different columns of interesting metadata, and think of your logs that might have lots of metadata. And we said, hey, a lot of that stuff looked fine from the perspective of this analysis. But what we found was there's actually two types of results we might find. One is there might be basically maybe this massage parlor is a brothel. I'm going to make no value judgment or moral judgment that may or may not be illegal in different jurisdictions in the US. And so those are all marked in pink. But what I'm absolutely completely against is actual straight-on human trafficking. As an immigrant, like I feel very sensitive to that. So, and that's actually ingrained. And what we're doing here is two things. So ahead of time, we ran deep learning, TensorFlow, to just basically try to classify, hey, what are the, like, bad or not, like, gray, pink, or green. But then when we ran it through UMAP, we actually used a very generic algorithm to say, hey, without doing any of that training stuff, so imagine you just ran a log search and you just ran it through UMAP, cluster it for me. Like, show me what there is to see. And actually, that's basically what we're saying is like, how well did UMAP do relative to fancy machine learning TensorFlow stuff? And the result is actually kind of surprising. So for example, all that gray stuff, yeah, hey, it's all neutral. Don't look at it, same results. But then over here, what we're starting to see is more interesting stuff like, oh, I think this is potential human trafficking activity here that may kind of overlap with just like normal brothel-y stuff. And so now we can actually, as an analyst, I might want to start, clicking on the actual reviews, drilling in, things like that. And again, I can't actually do it in this talk. So the first thing that's kind of interesting is that in about 1 hour, I had a very similar result as the real machine learning team in about, like, I don't know, a month or two. There's still reasons you need to do the machine learning stuff, but just like as an analyst trying to do stuff quickly, I think this is an interesting result. Now, UMAP still struggles though. So like, remember I was talking about when we're doing these kinds of algorithms, it's really just working on like numeric ranges. Like that's really what it's primed for. There are tricks you can do to do things like categorical values, like maybe if it's a particular IP address, you make it a 0 or 1, stuff like that. But in practice, there are a lot of issues. So I want to take that same data, and now we're going to do the graph analytic perspective on it. And so we're actually going to reuse the machine learning results. It's peanut butter and jelly. We're going to pull out using one of those workflows, and this actually we're just using Splunk queries. So imagine doing this in Cousteau. We just searched for, let's say, the 5 or 100 most suspicious companies. Let's just, for each one of those, let's do a second search to say, hey, show me the reviews on it, show me maybe the corporate metadata. And then where it gets interesting as an analyst, I might want to ask, because now I want to find like a crime network. Like for that region of the world that we're analyzing, my guess is if there's one group, like people don't do crime in isolation. There's a support network, there's a supply chain. So if you think of like malware, if you think of phishing, same thing. There's a supply chain behind how this stuff happens. There are different actors doing different stuff. And so the guess was, if we looked up all those businesses and we just did a second log search to say, hey, what else is there? And if we could just expand on all of that metadata, and then we can actually see the result, then maybe we can start seeing things. And that's actually what happened. And so, and green is just like geographic information. But the interesting thing here is, for example, we started popping like phone numbers and individuals. And again, I'm not saying anybody here is actually a known bad actor. This is like an ongoing thing. But they're involved in kind of a community that in whatever way at an official level where we have to start thinking about it. And now from a graph clustering view, a little closer to how an analyst might really want, now that we've done the data foraging, now I want to do the sense making. Ran the same thing. I just changed the layout from kind of like showing how the investigation frill. Now I'm actually doing based on clustering. That same exact result, just a different layout algorithm. I have a guess that if I was going to, for example, pick which group to investigate, I'll probably pick the bigger one. And then if I was going to pick a starting point, I'd probably, and blue in the center is an email address. So I'd probably try to figure out things about that email address. And again, like, I think the UMAP stuff has value. There's a reason we do that with teams. But at the same time, Graph does actually let us do things with that same data and make other kinds of insights that may not be as easy when we're just doing this world. So both have their place, but hopefully that's a nice example of where one helps more than the other. Okay. So I'm going to share a couple more examples here of just using this stuff in action, then talk about GPUs. So maybe actually more just as a flyby. I thought it was interesting. So Matt was sharing an example where he was looking at, hey, for out of all of the events or alerts that the 365 team or SharePoint team was seeing, can we see those like as a map? And Graphistry was interesting is even without doing the model work, what we could do, for example, is, hey, let's take 1 week of all of our FireEye host alerts, or let's take 1 week of all of our filed incidents, run the search query against whatever our SIM is, and then just map out the hypergraph and see 1 week of activity. And so here, what we're seeing is this is the hypergraph view. So for example, we see in red are individual, imagine like a signature or something like that, like a takeover. And then in blue are the devices, and then each orange is like a log line. And so what we're seeing is, for example, on the bottom right, 1 alert was hit by a lot of users. This looks like fewer users were hit by this one, but there's actually a lot more log activity. And so we can actually do that kind of stuff pretty easily now. And so I thought kind of reinforcing Matt's point, like we find that's kind of an interesting one to do with teams. Okay, I'm going to shift gears a bit to GPU land. But to do that, I think it's nice to do an example. So sometimes, especially if we're doing hunting or we're dealing with very intensive things or longer time scale, we will have to deal with more data. That might be because we just have a lot more rows because of the longer time period, or maybe we have a lot more metadata, things like that. What's interesting is often if you have good algorithms, the algorithms will surface structure to that data. So in this case, for example, we're looking at just internal network traffic. Again, this is actually a simple view where nodes are devices, and then each edge is just a very simple, did one computer have a flagged communication with another? So for example, here we're seeing a lot of this computer was triggering a lot of firewall alerts on the computers over here. What's kind of nuts is, so first of all, this is actually not a big graph to the Graphistry team. Like to us, this is like a nice medium-sized graph. But what we're looking at here is like, yeah, all right, 64,000 internal devices or entities or whatever returned from the search. Fine, put it on screen. I could cluster it. I could play with it, stuff like that. And then I can actually interact with it. So for example, I'm noticing there's a lot of this gray noise, that this firewall stuff. So like, let me just get rid of all the gray stuff. So I'm just going to do more of like the second tier stuff because I already understand that there's some certain firewall gray stuff going on. And now I could just recluster, and it's just fast. And now I actually see there's actually other behavior going on. So for example, I don't know, there's 3 other devices here. It's mostly, I don't know what yellow is. Yellow is some OS Microsoft log, and then brown is some sort of net screen. And so, but I'm able to quickly do that kind of thing. Like as soon as I do the search, I can actually make sense of the events and entities behind it and drill around. Underneath what's going on is we're using GPUs in the browser just to visualize it, sort of like a video game. But actually on the back end, we're using GPUs in the data center, and we're actually running interactive analytics there. And that's what I actually wanted to talk about. So let's jump ahead. So in Azure, you can now, like, if you wanted to spin up like a node with about 100 gigabytes of GPU memory and start doing crazy stuff with it, that's going to be about $5, maybe more, maybe less, I don't know. So instead of a coffee, do crazy supercomputing. And kind of a sense of what's going on there is, it's still early, so you're definitely beyond the edge if you're in this world. To give a sense is like a few years ago, we did an NSF project where we introduced the notion of a GPU data frame. NVIDIA, unsurprisingly, liked it. And then a bunch of startups started doing stuff. And now we're actually at the point where we have an open source ecosystem, so you can actually just go. And if you want to write SQL that runs on GPUs, you want to do graph algorithms, again, Brad Reese, I'd recommend you talk to, you can actually go. So as a couple examples here, just to make it kind of concrete, let's say you're in that notebook, you're writing those queries. Even without graph, like let's say we're just doing NetFlow logs, I might want to like bundle the logs based on the source and dest IP pairs and just see what's like for each one, when's the most recent time they talked or something. You could run that. And what's interesting is if you're working at interesting scales, if you do kind of for example, like a speed plus cost analysis versus say Spark. And the way I like to talk about it is on 2 dimensions. One is, let's say there's a 100x differential. So maybe we use 10x to go 10x faster than Spark. And instead of going 100x faster than Spark, we just keep it at 10x faster than Spark, but then we also go 10 times cheaper. And so you kind of pick, do you want to be like, 100 times cheaper but with the same result, or do you want to go 100 times faster and pay the same amount, that kind of stuff. You can actually start playing with those things. So that's about the data frames. cuGraph I found was interesting is that's kind of a newer part of the project. But on a multi-GPU scenario, for example, we could take I think this is 16 billion edges, and then in 30 seconds, you could do stuff with 16 billion edges, which you could do bigger data sets, but that should get a lot of people pretty far. I normally work with more at the mid-level, but I found that impressive. And also, I'm going to shout out to Blazing SQL, which is an open source SQL that kind of plugs right into the system. So all that to say is you can actually do GPUs now. And my claim is if you're doing more like hunting type stuff or larger scale stuff, this is actually starting to become interesting to look at, and lightweight methods are now practical. Last bit, I just want to chat about this slide is, I almost made this entire section of the talk, but of just having it I think is important. Recently, Gartner did an analysis, and this is the same people, Gartner's the people who kind of like push all this technology on everybody, so that's their job to push technology, and yet what they did a recent analysis, about 85% of data science projects fail. This is just because it's hard. It's like multidisciplinary data science, data engineering, all this stuff, but it's still worth doing, and graph is very much a data thing, so we need to have an answer to this. And so over the years, my team's kind of learned a few things. One of the things I've learned is basically do things that you can be successful on like one day or 1 month and grow from that. A lot of teams I'll talk to, they'll say, hey, let's start by doing a big graph database initiative. We'll do, get our Kafka pipes all rerouted. We'll stand up this giant multi-available graph database, do a bunch of data cleaning, and then maybe in 3 months we'll talk to users. That's a project that's doomed to fail. Like maybe you're big enough and have enough money that you can work in a silo for 2 years, but what we found is for most teams, especially with like very political environments, start small, work with the users. Actually, like if you can even solve one problem for one user, you could then go to management and just like that's your slide that you can just like, look, no, we were really doing valuable things here. You have that like defensibility. Another way of looking at a fairly similar thing is the Cupcake Principle. Even if ultimately you're going to a big thing, don't start with building the multi-layer cake. If you make one useful cupcake, use that to grow. And then finally, kind of as this is actually true of technology in general. So if, maybe the meta level is there's something called the Diffusion of Innovation, which is a study of how technology gets adopted in general. And so for anybody here working at the edge, it's a useful model of, it's actually data-driven for how this stuff works. But basically, two of the tricks there. One is low switching costs. So one of the ways to have low switching costs for your teams is actually to have zero switching costs. Don't ask people to throw anything out. You are not replacing a system. So asking somebody to replace a SIM with some graph database or to replace their existing like correlation tool with some new thing, that's actually that's a political battle that if you can avoid, you can actually want to do the same project, but if you can phrase it as something that's augmenting, that's all of a sudden, oh, there's something we couldn't do today. You can keep playing in the old sandpit, but if you want the new toy, here it is. That's actually helps a lot. And then the other part is to start working with champions. And by that, what I mean is, one is, don't work with everybody. Just work with a few people. Hopefully they're technical. Hopefully they're innovative. Hopefully they're patient. They could deal with the hard edges because you're trying to do something new. And if you're doing graph, most people on your team they're probably thinking about going to the bar on the weekend or seeing their kids. They're not thinking about doing this stuff. So I would recommend find that champion, find that good, like, hey, here's some use cases we can do, and just build out from there. Build that cupcake, get everybody addicted to it, and grow out from there. Anyway, that was a lot of stuff. So scaling graph apparently is not, you can't just solve it like in one afternoon. But hopefully, as that stuff scales and matures, some of that stuff will stick with you, whether you're a user or you're building systems. Some of the ideas I think are very powerful here were, again, virtual graph and hypergraph. So we have a computational substrate where we can actually build really cool stuff. We were already leveraging it at Graphistry to make automation something that can happen during an investigation, not just before an investigation. So happy to chat about that. Graph Viz can be useful. I'll disagree a little bit with earlier speakers. Just because tools stink at big graphs doesn't mean that's inherent to the problem. And then finally, I think the GPU stuff is worth taking a look at, and then that really dovetails to that second point is like if you do want to live on the edge like that, you should totally do it. With a little bit of upfront planning, data projects are data projects that take care. I think I'm right at the time on this one, so I'd recommend maybe just step out for questions or something.
Yeah, so unfortunately, we don't have time for questions. We'll stop here and take a 10-minute break. But before that, let's give a great round of applause to Dr. Leo. Cool stuff.